All right, well, it's time to begin. Good evening, everyone. Welcome to the research seminar of the Center for Institutional Studies at the HSE University, Moscow. We're very pleased to welcome as our speaker tonight, Andrey Tkachenko, also from HSE University. Andrey's academic background involves Moscow State University, where he received his bachelor's in math and defended a PhD dissertation in probability theory. His master's in economics is from HSE. He specializes in public procurement, probability, and applied econometrics. Andrey's presentation tonight is about the competitive effect of vertical integration in auctions. I would like to ask everyone to please register yourself in the chat column of this Zoom session. And Andrey, the floor is yours. Thanks.
Thank you very much. So now I start sharing the slides. Can you see them well?
Yes, yeah, you're okay, please. Everything's fine.
Frankly speaking, I cannot see the chart right now during the presentation. So if, Bernardo, if there are some questions, can you interrupt me, please, okay?
Yes, I will, because also you will see many messages of people just writing their names and affiliations. So I will keep an eye on if there's any specific question, I will let you know so you can answer it.
Okay, thank you very much. So today I'm presenting the paper, The Competitive Effect of Vertical Integration in Auctions. This is a quite new paper, so I would appreciate questions, remark on this, and thank you for being here this evening or afternoon. I appreciate it as well. So what is the effect of vertical integration in auction on consumer prices? This is a controversial question, both in empirical and theoretical literature, because vertical integration, on the one hand, can generate cost efficiency because the downstream firm can get the product cheaper from the upstream firm if these two firms are vertically integrated. And if this cost efficiency is passed through to the consumers, then the consumer prices are lower. On the other hand, vertical integration can generate foreclosure when the vertically integrated upstream firm, it can have incentives to increase input cost of rivals of the vertically integrated downstream firm, and then the consumer price will increase. Therefore, the overall effect of the vertical integration is ambiguous. And the large vertical mergers in different industries like telecommunication and healthcare in recent years resume this debate question about vertical integration. In this paper, I studied the role of vertical integration in pharmaceutical industry, and this industry is quite remarkable. It has several important features. First of all, the supply side of this industry is vertically structured. At the upstream level, there are producers who manufacture drugs with different trade names, but these drugs may be very close because they use the same active ingredient, and so the therapeutic treatment is similar. At the downstream level, there are distributors who take the drug from the producers and spread them out to the final consumers. In many developed and developing countries, public buyers like hospitals and ministries of health constitute a large share of the demand in this market. Their incentives is to intensify competition, and they can do it in two steps. First, they can consider drugs with different trade names, but with the same active ingredient and dosage as similar drugs. And in doing this, they intensify competition among producers at the upstream level. In the second step, the public buyers may make to compete distributors solely in price for auctions, and so they intensify competition among distributors at the downstream level. Therefore, the marketplace where the public demand meets the supply are public procurement auctions. In this paper, I take the setting where the downstream competition is organized through procurement auctions, and I studied two questions. First one is, what is the effect of vertical integration on procurement prices? And the second, how this effect depends on the market structure at the upstream level. I studied these questions in two ways. First, I construct an auction model where the bidders can have vertical interactions with upstream input suppliers. And this model gives me two testable predictions. Next, I test this prediction using Russian public procurement data. This data has several advantages. First, it has quite detailed information about auctions and drugs procured through them. Second, public procurement in Russia constitutes around 31% of the overall demand of pharmaceutical drugs. So it's quite large. And finally, the pharmaceutical industry in Russia is quite dynamic. It has many vertical mergers and divestitures. So let me give you the preview of results. If there is only one producer at the upstream level, then my theoretical model and empirical findings show that there is no effect of vertical integration on prices, on procurement prices. However, if the number of upstream producer is small, but there is still competition at the upstream level, then after the vertical integration, procurement prices increase by 13% in auctions where the vertically integrated distributor is one of the participants.
Excuse me, Andrey, I think Vitalis has a question. He raised his hand.
Yes.
Yes, I have a very clarifying question about the research question. So I'm a little bit rusty on my IO, but then why do you focus on upstream competition? Because I would think that, you know, we have two markets like upstream and downstream. And if I remember correctly, and I might be wrong, so, you know, if we have upstream a monopoly and downstream monopoly, then, you know, two monopolies are bad, then it's better to make one monopoly. So it's kind of theory would generate predictions that allowing vertical integration between two monopolies should bring prices down. Why don't you test this kind of hypothesis?
Yes, thank you for this question. Yes, you're absolutely right. So the vertical integration of two monopolies is better because it reduces double marginalization, correct? But things become completely different when we come from the monopoly to the oligopoly cases. And Riordan, for example, in his papers show that the effects might be quite unexpected. And we will see that these effects exactly different sometimes from what we can expect.
So Andrey, are you trying to say that there is no theorem that tells you the direction?
There are theorems of the vertical integration with monopoly and, let's say, duopolies at the upstream and downstream levels. But to my best knowledge, all this research, and I will tell about this a little later, they consider downstream competition in retail markets. That is, products are differentiated at the downstream level. And in my setting, I will consider competition in the auction setting at the downstream level, where products are not differentiated. And this distinguish is quite important because, let's say, even if the cost efficiency, if the vertical integration generates cost efficiency, in the differentiated case, in the case of differentiated products, this cost efficiency might not be passed to the consumers because they do not value this. Some of the consumers do not value this cost efficiency.
Well, sorry, Andrey, because why I'm asking, because it seems a little bit artificial. You know, you're saying, okay, fine, I will focus on upstream market where, you know, there is some competition, but in this data and in general in Russia, you'll have a huge variation in downstream competition, right? I mean,
correct.
And so you know, it's kind of a little bit strange that, in a sense, you have a clear theoretical prediction which you could test, right? And then to see whether this holds in the data and then go to something more complicated, whereas you start with the most complicated result, with the most complicated setting from the very beginning.
So let me try. There are two questions as far as I understand. First, there are papers which study the competition at the upstream level, given the downstream competition fixed. This is exactly what I do. but these papers are theoretical, only theoretical. There is no empirical papers which study this. And as I already said, these papers assume that the competition at downstream level is organized for the differentiated products. So I agree, absolutely agree that the results might be quite theoretical, but on top of the theory, I show that it take place in the data. So this theory is quite supported by the data. And what I show empirically, so my results vary. So my estimation procedure allows for the variation at the upstream level, fixing or giving the competition at the downstream level. So I control for number of applicants and so on, and
so
I will explain this later.
I think that's a very complicated part to control for the number of applicants.
Okay, guys,
the results.
I suggest to move on, please. You made your point, and at the end of the presentation, we'll be able to get back to that issue.
Okay.
Unless there are any other questions to ask right away, I would suggest Andrey to proceed, please.
This is just one comment of Sergei Popov in the chat. He said that
Sure.
number of competitors could be endogenous to whether the specific auction is corrupt. I don't know if you want to comment.
Okay, okay. I will come to the corruption problem at the end of my presentation, and I control. I have a way to control for this, and I show that my result will hold even in this case. Okay. Okay. So, what is the contribution of my results? As I already pointed out in the discussion, that I first contribute on the effect of the vertical integration, and main contribution is that I take the auction setting at the downstream level, while other papers show the effect of vertical integration where the downstream competition is organized for differentiated goods. And the papers, which we also already pointed out, the Lochester and Reisinger and Lochester de Riordan, they have quite the similar setting where they also show some theoretical results with respect to the number of firms at the upstream level. My second contribution is on the empirical literature on consolidation in pharmaceutical industries, where all the literature I know about show the effect of the horizontal mergers on the pharmaceutical prices. And I show the effect of the vertical integration. I also contribute to the literatures on public procurement of pharmaceutical drugs and on the literature about the effect of the market structure on auctions. So let me go to the theoretical model. This model will explain some mechanism which I will then show in the data. At the upstream level, there are n producers who manufacture the same drug. And at the downstream level, there are m distributors who would like to participate in the auction of the buyer. At the first stage, upstream producers observe independent private value, production cost UI, and then each distributor negotiates an input price with all the producers and choose the minimal one. The negotiation protocol is the following. If there is only one producer at the upstream level, then this producer is just price setter. And so the negotiation somehow is redundant. If there are several producers at the upstream level, then each distributor runs an inner descending English auction among all the producers. And this is how I model the negotiation. Let me explain why the English auction is a proper way to model negotiation in this case. So indeed, each distributor can call to different producers and play them off against each other up to the point at which price offered by the lowest cost producer cannot be profitably beaten by any other producers. And this is exactly how the English auction is organized. So next, at the second stage, the distributors observe independent private value costs, delivery costs, DJs, and then they form the total cost, which is the sum of the input prices and delivery costs. And finally, all the distributors participate in a descending English auction of the buyer. In this model, I assume that at least 2 distributors participate in the auction. So in this version of the model, I ignore the reserve price, so I assume that the reserve price is not binding. And yeah, so let's keep this one. I will consider 2 scenarios. The first one is non-vertically integrated scenario, where all the distributors and all the producers are independent firms. And the second scenario is vertically integrated one, where the first producer is vertically integrated with first distributor and other firms are independent. The goal of this model is to compare ex-ante expected payment of the buyers in the scenarios of non-vertical integration with the scenario of vertical integration. So let me solve this model backwardly, starting from this stage 2. And I first consider the scenario with single producer. Since all the firms are independent, the distributors stay in the auction until the current price reaches the total cost, and the distributor with the minimal total cost wins the auction, and he gets the payment equal to the second lowest total cost, as in standard English auction. Next, at the stage 1, the producer sets prices to all the distributors. And since all the distributors are symmetric from the perspective of the producer says the same markup to all the distributors. Here I assume that the markups are bounded above by the mu bar. So this mu bar actually implicitly inheres the reserve price. So I assume that, for example, the producer cannot put the reserve price, the markup too much, too high. And so it is bounded above. And since the single distributor is profit maximizer, he chooses the maximal available markup mu bar. And so the expected buyer payment in this case quite simple. This is a cost of production U1 plus maximal available markup mu bar and the second lowest deliver cost. So next let me consider the case of single producer with vertical integrated scenario. In this case, the vertically integrated distributor 1 can get the product at its production cost U1, and so he just adds the deliver cost to it. At the same time, other distributors have markup in their total cost structure. Because the first distributor is vertically integrated with the first producer, he knows the markup mu which the producer sets to other distributors. And let me recall that he participates in the English auction. And I show that in this case, the vertically integrated distributor has no incentives to stay in the auction until the total cost, but rather he stays in the auction until the total cost of non-vertically integrated scenario, which is represented in Formula 3, because he knows that if he loses the auction, the vertically integrated upstream producer will get profit mu anyway, and therefore he gets out of the auction earlier than his total cost. Therefore, the behavior of the vertically integrated distributor in the vertical integrated scenario is the same as in non-vertical integrated scenario. And finally, at stage 1, the single producers again set the maximal available markup mu bar, and we come to quite expected result, which is presented in proposition 1, that if the producer is unique, then expected buyer payment before and after the vertical integration is the same. That is, the cost efficiency which the first distributor gets is not passed through to the consumer, to the buyer. Next, let me consider the case of several producers at the upstream level and non-vertically integrated scenario. Again, at the stage 2, all the distributors are independent. They bid up to the total cost. Again, the lowest cost distributor wins, and he gets the payment of the second total cost. But at the stage 1, we now have the negotiation process, which is modeled through the English auction. Therefore, the input price of each distributor is the second lowest production cost, U to N. And therefore, the expected buyer payment in this case also quite simple. It is the expectation of the sum of the second lowest price production cost plus second lowest delivery cost, which is represented in Formula 4. And finally, I consider the most complicated case with several upstream producers and vertically integrated scenario. First, vertical integration generates cost efficiency. I parameterize it through delta, and I interpret this cost efficiency as negotiation cost. Because the first distributor does not need to pay the negotiation cost to the vertically integrated producer, he can get the product from the vertically integrated producer at the price U1 minus delta. And I assume that delta is exogenous and common knowledge of all the participants. On the other hand, vertical integration can create incentives for the first producer to foreclose the rival distributors of first distributor. Indeed, if the first producer increase his price, that is, he adds the markup mu, at the negotiation stage with rival distributors, on the other hand, by doing this, she decreases the probability to win negotiation process of the rival distributors. But on the other hand, the first producer increases the input price of these rival producers. And this is exactly how the rising the rival cost appears in the model. Of course, this strategy, this markup mu, is an endogenous, and this is strategy of the first producer. So now let me solve the model again backwardly at stage 2, and I consider 2 cases. The first case, when the price of the first producer is below than the cost of all the rival producers. In this case, the first producer is the input suppliers for all the distributors, and we are back to the case of single producer. That is, again, the downstream distributor has no incentives to stay in the auction up until the total cost, but he stays in the auction up until cost U1, up until the cost represented here, as if he is not vertically integrated. In the second case, when the upstream producer is not the input supplier for all the distributors, then all distributors stay in the auction up until the total cost, as in the standard English auction, but the total cost of all the distributors are different. For example, for the first distributor, the total cost is the minimum between the cost which he can get from the vertically integrated producer, U1 minus delta, and the cost which he can get from rival distributors, U2N. Plus he adds the delivery costs. On the other hand, the total cost of rival distributors is the second lowest cost of production, where the first producer, instead of playing U1, she plays U1 plus mu, and so she increases the input price of the rival distributors. And the upstream rival producer can anticipate this behavior of first producer, and so she can give additional discount raw or rebate raw to the winning bid at the negotiation stage.
Excuse me, Andrei, there is a question in the chat by Vitalis.
Yes.
I think Vitalis, you can ask it aloud.
I have a very simple question. Are you assuming that upstream firm can satisfy the whole demand downstream?
Yes, I assume like this because of two reasons. In the data, what I observe that in most cases, when the contract is implemented, there is a product of only one producer. These are quite rare events in my contract data when I observe two different products for the same drug specification. I mean, for the same drug specification, that is fixing drug specification, I observe only one producer. And usually the auctions are not so large. Of course, there are some large auctions which Federal Ministry of Health sometimes run. But again, usually these auctions are for the monopolistic producer, in which case this producer should supply all the demand. Thank you for this question.
Because, sorry, just to clarify, because I was thinking that, you know, so I still don't understand one assumption. So suppose there are like, you know, 10 suppliers that want to participate in an auction. And are you telling to us that, you know, they negotiate, let's say, with an upstream firm? And this upstream firm is then, you know, will sell its drug only to one of them out of these 10.
Okay. Thank you for the question. No, I do not assume that upstream firm will sell to only one. No, they each distributor negotiates with all the producers. In the equilibrium of the vertical integrated scenario, the integrated producer actually may sell only to the vertically integrated distributor, and this might happen in equilibrium. That is, for example, his price, his markup mu will be so large that nobody will want to buy from him because the rival producers give low prices. But I do not assume that they completely foreclose or each producer stick to only one distributor. No, I do not assume this. Okay.
I also ask one clarifying question because I didn't get at which point the producer should transfer the product, the drug, to the distributor, because it seems not clear. They negotiate at stage 1, but it seems due to your results that they are not buying at this third stage from the producer, because then you should have other results.
You are absolutely right. When I discuss with producers, actually, this is exactly what happens. The distributors call to producers and negotiate input price conditional if they win the auction. That is, if they win the auction, they will come to this producer and take the drug. If they lose, there is nothing. Nobody buys, nothing happens. Did I answer?
Yeah, sorry, you are implicitly suppose that there is no normal market, only procurement market, and that's it.
Yeah, so I assume like this, and when I discuss with the producers, they are trying to control this. They are trying to split the retail market and the public procurement market. It's not always happen. But if we, let's say, if we consider quite large auctions, then in these auctions, the distributor should provide a document from the producer that this producer is ready to supply the drug. And this is the necessary document, obligatory document. So without this document, the distributor will not pass to the bidding stage. Therefore, they need to somehow to negotiate with producer about what type of products will they put into the retail markets, and what type of products, which tranche of products will they pass to the public procurement market. Okay.
And also just one question, and also you assume a very basically, because I was thinking that you're basically assuming that there is negotiation period by period, right? That
yes.
So all dynamics are assumed away, right?
Yes. So I fix one auction and all the dynamics within this auction. Again,
but sorry. Do you have any ideas? Just again, this is just a clarifying. I understand it's not a dynamic setting, but then how would your results change if if they form some kind of long-term relationships? Because I think that this is the case, right? So I mean,
actually, what is again from my discussion with the producers, if the auctions are large, what they say larger than 10 million rubles, this negotiation occurs for each auction. That is, at the website, at the closed website for the distributors, each producer has a list of prices. And then when the auction is announced, the distributors can call to producers and negotiate additional discount to this list. And this, for large auctions, this happens for each auction separately. Of course, for small auctions, it's not the case. And they do not negotiate at all, so they can take the products from the retail markets to the public procurement market. And of course, this negotiation does not happen because the negotiation cost is larger than, let's say, the profit they can get. But for the large auctions, it is the case.
Yeah, thanks.
Okay. So what is now let's come to the stage one. So what is the equilibrium? Equilibrium are the strategies mu and rho, which actually are functions of the observable states. These strategies should maximize the expected profits of the vertically integrated firm, which is producer and distributor, and the non-vertically integrated rival producer. The first component of the Formula 7 is the payoff of the vertically integrated firm if the upstream producer is the only supplier to all the distributors and the distributor one wins the auction. The second component of Formula 7 is the profit when the upstream producer is the input suppliers for all the distributors and downstream distributor one loses the auction. And let me recall that in this case, the upstream vertically integrated upstream producer still gets some profit because he's input supplier for all the distributors. And finally, the third component of Formula 7 is the expected profit when the producer one is not an input supplier for all the distributors and the downstream vertically integrated distributor wins the auction. To find the solution of this game, even for quite simple distributions of U1 and D1 is quite complicated because it's not easy to write down these expressions in the terms of primitives of the model. Well, it's possible. But this model has quite remarkable result, which is represented in proposition 2. Namely, if the cost efficiency is positive, then for any foreclosure effect mu and any rebate which rival producer is ready to give, and if the number of producers is large enough, then expected buyer payment in the case of vertically integrated scenario is lower compared to the expected buyer payment in non-vertically integrated scenario. That is, in this case, the cost efficiency dominates foreclosure. And the picture shows this, exactly this. So we see if the number of producers is large enough, this difference, which is showed on the y-axis, is negative. That is, cost efficiency dominates. But if the number of producers is low, let's say 2 or 3 or 4 even here, the foreclosure effect dominates, and vertical integration is harmful for the public buyer. So now I think I gave some hint about what mechanism can drive the results, and let me go to the empirical part. Let me first explain the procurement institutions and setting, and then I will show the...
Sorry, Andrey, Vitalis has 2 more questions.
Yes, yes.
A very clarifying question. Do you prove that the equilibrium exists?
I do not prove it. This is quite standard game, so it should exist, but I'm still in the process.
So, okay, is it unique? No, I mean, in a sense, you know,
so it might be not unique. So, and let me show that they might not even play the equilibrium, the vertically integrated producer and the rival producer. But this result is quite remarkable because whatever actions the vertically integrated producer and the rival producer do, if downstream distributors will play with respect to weakly dominant strategies, the effect of the vertical integration is pro-competitive.
Sure, but this doesn't have an empirical content, right? N tends to infinity doesn't say anything, right?
No,
what is n to infinity? For this particular distribution, yes, but if you take another one.
No. This is general result for any distribution with finite support.
Sure, but you know, what does it mean in the data n to infinity?
In the data, it means that if the number of producers is large, what means the limit, the n tends to infinity? It means that there exists, let's say, n bar, some threshold, such that if the number of producers is larger than this threshold, the difference will be negative. So for this distribution in the picture, this threshold, let's say 4. For other distributors, it might be 5, 10, 11. But what I want to show, this threshold exists for different drug specifications.
How do you find this? So do you solve for the equilibrium?
No.
Yeah. So this is what I'm doing. I'm in the process of solving the equilibrium. But what I want to emphasize, that even if they do not play in equilibrium, the vertical integration is pro-competitive. So I do not impose them to play in equilibrium. I mean the vertical integrated producer and his rival. What I only assume that downstream distributor will play with respect to weakly dominant strategies, which is very strict, very rational behavior. Therefore, even if the equilibrium doesn't exist, but I believe that it exists, or even if there are several equilibriums, this result will hold and for equilibrium as well.
Okay, well, Andrey, this picture, is it a result of some simulation? Or what? How did you get this?
Yes, sorry, yes, I should explain. Yes, this is a picture of the result. This is a result of simulation, where I take the upstream and downstream distribution uniform with the discount, the cost efficiency delta equals 0.2, and up to the moment I take rho equals 0. But of course, if I take rho positive, the picture will go, the limit will be even below, because rho gives additional discount.
And what are the distribution that you assume? You said finite distribution.
Uniform, yes.
And you observe that this effect kicks in for a relatively low level of participants, right? 5, 6, you already have it,
yes.
Okay?
Yes, I have it.
And then just for a second, going back to this uniqueness question, which is a valid one, you argue that even if there are multiple equilibria, this weakly dominant strategy would be the same, irrespective of the number of equilibria. So you can talk about some.
Yeah, so the weakly dominant strategy of the downstream firms is fixed, and they will always.
Because you're not assuming any selection procedure, right, among this equilibria, right? So
no, I don't assume any selection procedure. No, it might be any equilibrium at the upstream level, but at the downstream level, they play with respect to weakly dominant strategies.
Okay.
So Andrey, I just don't understand this result. That's the problem. So basically, you aren't telling us. Okay, so suppose, let's assume that. So I have problems with these prices. These prices are coming from some kind of equilibrium behavior. You're telling us that, you know, even the equilibrium doesn't exist, but downstream there's a weakly dominant strategy, whatever that means. These prices somehow magically appear, and actually, they are smaller than zero in the limit. This difference smaller than zero in the limit. Is this correct?
I do not assume that they play equilibrium. Playing equilibrium is a hard assumption, is a strict assumption, playing equilibrium. It not always, and there are many of literature show that people do not always play in Nash equilibrium. They might deviate from the equilibrium. And I show that even if the upstream producers might deviate from equilibrium, or even if the equilibrium does not exist, they might play very weird strategies at all. The downstream firms has very hard behavior, very strict behavior. They play with respect to weakly dominant strategies. They have no incentive to deviate at all. And then this result will hold. But I absolutely agree that I should solve for the equilibrium at least numerically and show that it will hold as well, that equilibrium exists. I agree, absolutely. At least one equilibrium exists.
But Andrey, there's also one question from Ricardo in the chat. Sorry, Pavel, go with your question and then Ricardo, please.
Thank you. So it's just, you're saying that you don't know how to solve for the equilibrium, but you show us the picture where you solve for the outcome of the model. So it seems that the picture has some unknown inputs, like the strategy that the other guys are playing. So how do you compute it if you don't know the strategies?
You're absolutely right. Thank you for the question. Let me point out that I assume rho equals 0. So the equilibrium is the pair mu and rho. In this picture, I assume rho equals 0. It might be not an equilibrium. But if I assume rho equals 0, then I can solve this equation already more or less through the simulations, because I can simulate these probabilities. Okay? And what I say that even when the rho is positive, this difference will be even more negative, because rho is additional discount which the distributor has.
Ricardo also sent a question in the chat. I don't know, Ricardo, if you want to ask it aloud.
Yeah, so I mean, as already highlighted by others, the result of proposition 2 is true for n that goes to infinite, but the point where this result starts to be true really depends on the cost distribution. So I do wonder if you can recover somehow the cost distribution from your empirical data. I mean, there is a large bunch of literature that recover the cost from the observation of the bits. So that's the question.
Thank you for the question. Yes, this is what I'm working right now at. So as you can see already, it's quite hard to, even at this moment for me, it's quite hard to solve this, and so to recover cost even more harder. So I'm thinking how to do this. So of course, it's possible to write the structural model and solve it, and then recover the cost structure. But at this moment, what I present is that whatever distribution we take with finite support will have this result. And now I just want to show that this result holds in the data. And my future research will try. In my future research, I will try to solve this model. Solve this model and then recover the cost distribution.
Okay, fair enough. Let's have a look at the empirical part if no one has any objections, because we're running out of time.
Thank you.
Yep.
So what is public procurement in Russia? It constitutes around 31% of the overall demand of pharmaceutical drugs. And for example, in 2018, it was $8.3 billion US. So it's quite a large portion. The buyers are federal and regional ministries of health who wants to implement social support programs, and hospitals or polyclinics who buy the pharmaceutical drugs for their everyday needs. The bidders mostly are distributors and pharmacy networks, and sometimes I observe in the data that producers also participate in the auction directly. So how the auction is organized? First of all, the buyer should describe for each drug in the bundle the set of characteristics. The first characteristic is the drug specification. By the drug specification, I understand the following combination. It's active ingredient, but not the trade name. Then the dosage of this active ingredient and drug form. Next, the buyer specifies quantity she wants to buy, number of units in pack and number of packs. And finally, she specifies the reserve price per pack. Next, the buyer announces the procedure. Either in most cases, in dominant cases, these are electronic English open auctions. And sometimes I observe also seal bid auctions. I will show what is the proportion of this in my data later. Next, all the bidders participate in the auction by placing their bids for the bundle, and the minimal bid wins. And finally, the winner supplies the bundle. So I have data from 2015 till 2019. So my data includes population of procurement of drugs, procurement of anti-neoplastic drugs, antimicrobial drugs, and drugs for treating diabetes and diseases of circulatory system. Overall, it includes around 850,000 auction bundles corresponding to 26 million of drugs. And I observe for each contract the winner ID, the winner's price per unit and quantity of each drug in the bundle, and the trade name of the supplied drug and their producers, the producer of this supplied drug. So I have 9 corporate events with respect to vertical integration. They are 2 partial mergers, 3 full mergers, and 4 divestitures. In what follows, I will call the vertically integrated distributors as those distributors who are in the left column of this table, and vertically integrated producers are those producers who are in the second column of this table. This notation does not mean that other producers or other distributors are not vertically integrated. This just only means that the vertical structure of this firm did not change during this period of analysis. So in order to define or to identify the effect of vertical integration on prices, I first should define the market. So what is the market? I define drug specification as the relevant market because the public buyers announce exactly the combination of active ingredient, dosage, and issue form, the form of the drug. In my empirical part, I identify drug specification as combination of active ingredient and dosage because adding additional issue form or drug form is not important because I have almost one-to-one correspondence between triples and pairs of these clusters. The left picture shows the distribution with respect to number of drug specification producers in the data. And we can observe that around more than 800 markets are monopolized and around 700 markets have from 2 till 4 different producers. So they are quite concentrated. On the right picture, I show the same distribution, but only for those drug specification where the vertically integrated producer is one of the producers. So what we observe that around 60 markets are monopolized by this vertically integrated producer, and around 70 markets are quite concentrated, that they have from 2 till 4 different producers. This heterogeneity, as we already discussed, quite important for empirical part.
Can I have a short question? Am I right that this is just public procurement market? So when you're saying market, it's not a general market. And in the private market, it could be that you have producer that is not included here, but produce this drug specification too.
Absolutely correct. These are only public procurement markets. So these are producers who supply only for public procurement. Thank you. So next I show the descriptive statistics, and the first top table shows that the vertically integrated distributors supply drugs of both vertically integrated producer and not, as well as non-vertically integrated distributors also supply drugs of different producers. Next, let me discuss a little the descriptive statistics at the bundle level. So I have 96% of English electronic auctions, so only 4% of sealed bid auctions. The number of applicants in these auctions, average number of applicants, is 2.7, as well as the number of drug specification in each bundle is 2.7. The average share of drugs produced by vertically integrated producers is around 39%, and drugs produced by vertically integrated producers are in around 53% of the bundles. At least one drug is there. And vertically integrated distributors participate in 7% of these auctions, and they win 3% of these auctions. So let me explain the empirical strategy. I'm planning to use difference in difference approach with several treatment events, vertical mergers and divestitures. And the treatment group here is those drug specifications which are produced by vertically integrated producer. The control group should satisfy two conditions. The first condition, the control group should be somehow resemble the treatment group, because we need to have the parallel trends before the event, before the treatment event. But on the other hand, if the drugs will be very close to the treatment drugs, that is even substitutes, they also might be affected by the vertical integration. Therefore, as a control group, I chose those drugs which are produced by non-vertically integrated producers and which are in the same ATC3 level as the vertically integrated producer drugs, but not in the same ATC4 level. Let me give you an example. Let's assume that insulin glargine is in the treatment group. That is, it's produced by vertically integrated producer. Just a moment, I will finish and answer the question. Then the drugs at the 5th level can be direct substitutes to insulin glargine. So they might be affected by the vertical integration. Therefore, I do not take them in the control group. And in my control group, in this case, only drugs A10AC or A10AB will be in the control group. That is, all the drugs in the 4th level, which are not the treated drugs. You had the question? Okay, sorry. Then. And I will run the regressions for 2 different subsamples. The first subsample are auctions where the vertically integrated distributors are participants, and the second where the vertically integrated distributors do not participate. So my identification will be the following. Dependent variable is the logarithm of the price of the drug. Alpha will estimate the treatment effect at treated, and I multiply it by intensity, where the intensity is 1 for full mergers, 0.5 for partial mergers, and -1 for divestitures. I control for number of applicants. I put drug specification fixed effects because drugs are completely different. Different drug specifications are completely different. I put the within drug specification quantity quantile, year quarter fixed effect, supplier fixed effect, and buyer fixed effect. And I also control for the number of drug specification in the bundle, the duration of the contract, if the auction was centralized, and the auction type, either English auction or the sealed bid auction. So I cluster arrows in 2 ways, at the drug specification and at the bundle level, because drug specification in different auctions might be correlated, prices of drug specification in different auctions might be correlated, and because drugs in the same bundle, prices of drugs in the same bundle can be also correlated because they're supplied for the same firm. And then I run this regression separately for 2 subsamples, but there is a problem. Number of applicants is endogenous. I need to find an instrument for this.
Andrey, I'm sorry to interrupt. We are running a little bit out of time, so if you can please complete in about 5 minutes, we'll have some room for discussion. Thanks.
Thank you. So I use an instrument, the share of treated drugs in the bundle and its interaction with post-vertical integration event. So why this might be a relevant instrument? Because the high share of the treated drugs creates a higher cost advantage of the vertically integrated distributor, and the vertically integrated producer might have more incentives for closure. So why this instrument is valid? First of all, those are buyers who set the bundle. Next, I show that buyers do not deliberately give an advantage to vertically integrated distributors through high share of the treated drugs. So it is shown here, but I do not go deeply into the details. What I show that if the vertically integrated distributor is a participant, the share of treated drugs in the bundle is lower compared to the case when he is not a participant. And finally, I control directly for the number of drug specification in the bundle and drug specification fixed effects. So here are the results. So the first step shows that the instrument is relevant. Now let me go to the second step, and the main focus is on the coefficient AT-AT. So in columns 1 and 3, I show the result when the vertically integrated distributor is a participant, and in column 3 when he is not a participant. And we see that prices reduces by around 3.5% after the vertical integration. And this effect is heterogeneous in the upstream market structure. So if there is only one producer, there is no effect. If there are from 2 till 4 producers, we see that in column 2, the prices increase substantially by 13% if the vertical integrated distributor is a participant, but there is completely no effect if the vertical integrated distributor is not a participant. And finally, we see that prices of drug reduces by 3.8% if the upstream markets are quite competitive. Actually, my theoretical model explains the result of column 2, but not column 4. So how can we explain this coefficient? There is no theoretical model. There is no additional theoretical model for this in my paper, but I think this can be related to what Vitalis actually do in his paper. Actually, the auctions of different public buyers are not independent. When the public buyer sets the reserve price, she should take the contract price for the same drug specification in the past and set the reserve price with respect to this benchmark. So what I think here is occurs that the vertical integration reduces price in auctions where the vertical integrated producer participate, and this spill over to the auctions where the vertical integrated distributor is not a participant.
Excuse me, Andrey, and Sergey Popov sent a question in the chat.
Yes.
I don't know, Sergey, if you can ask it aloud.
I am very much not in the condition, but I just wanted to emphasize that there is no reason why not to do ATED for 2 producers, ATED for 3 producers, ATED for 4 producers. It's not important. That's why I left it in the chat.
Okay, so actually I varied this a little, but again, if you remember those pictures, there are not too many 2, 3, and 4 producers. There are quite a lot of single producers, but not too many of them. That's why I combined them together. And of course, I played with 2, let's say 2 till 5 producers as well. Thank you. So then I will not go into the detail about robustness check. So what robustness check do I do? So actually my model, if you remember, assumed that there are at least 2 bidders in the auction of the public buyers, at least 2 distributors. So I check my empirical results where I restricted the samples only for the auctions where there are only at least 2 applicants, and the results are still there, absolutely the same results. Then, as it was already mentioned, there might be a corruption or a favoritism or corruption, whatever you want to call it, and it might also affect the vertical integration. So I put procure supplier fixed effect, the joint fixed effects. So instead of 4,000, now I have 22,000 fixed effects here and 21, quite a lot fixed effects here as well. So results are still here, even after the control for the procure joint procure supplier fixed effects. And finally, I redefine markets and I add the geographical dimension. So I split the markets into the east and the west up to the Ural Mountains, redefine markets, and the results are still here. So now I conclude what we saw in this paper, that vertical integration are pro-competitive if the upstream markets are quite competitive. But if the upstream markets are concentrated but still competitive, the vertical integration requires special attention from the antitrust service. And if we do some simple back of the envelope estimation of the welfare, so in my data, public buyers spend around 1.7 billion US dollars, which is around 1.6% of the GDP, on drugs produced by vertically integrated producers, and 3.5% of savings, because the vertical integration can create the savings of around 60 million US dollars. So it's quite a lot. Thank you for the attention. This is it for today.
Terrific. Thanks very much, Andrey. Okay, Vasily Vitalis, you have a question, I guess, please.
Vitalis, your mic is off.
Can you show us a coefficient on the number of applicants?
Okay, yes, I can. Just a moment.
Can I see the number? I'm just, because, you know,
yes,
in my
yes,
paper,
yes.
I estimate exactly the same number.
You want the basic table, right? This one.
Yeah, on the number of applicants, right?
Yeah, so the lowest one. So -8, 7.6 for the vertical integrated and 4.5 for non-vertical integrated.
Okay, cool.
Okay, and there is a question from Pavel Andrian. Can you please look it up, or Pavel, maybe you can ask it yourself?
Pavel, if you can, because for some reason I cannot see the. I should open.
So can you read it?
I'll just speak it out. So
sure, please.
If you can solve for at least one parameter, which is rho equal to 0, you should be able to solve for nearby parameters as well. And technically, you should be able to solve for all parameters on the line by kind of slowly moving the parameter and using the previous estimate as a starting point for best response iteration. So this should not be holding you. You could be able to solve this model for rho equals to 0.5, for example, just as well. And then, but then you still need to stick to one distribution. Somebody might say, what if your distribution is special? You could draw 1,000 different distributions and then just say you tried them all. Well, this will amount to just repeating one estimation 10,000 times. Just run it on a computer. It will take a couple of days, and then you can report your results.
Thank you. Actually, this is what I'm thinking right now, and I even know how to estimate it directly. That is directly simulation, but this will take very long time, as you said, a couple of days. What I'm planning to do right now, I want to write those expressions analytically in terms of primitives, because it's possible, and I'm almost there. And then I can solve this numerically much faster. Again, through this iteration. So I assume one function for each step of iteration. I take, for example, rho function given, and then I find the optimal mu, and then take mu given, find the optimal rho, and then it will converge faster than just the simulation of the probabilities. But I do not say it's impossible. This is what I'm working at right now. Thank you for this comment.
And please, also, do you, so what happens if you redo everything like this on single product auctions? Because then, you know, here I don't see qualities and these kind of things. The things that, you know, drug fixed effects are also not there, etc., etc. You know.
Okay. So let me show you the full output. So it's actually in here, but it's in full output. So as I said, I put within drug specification quantity quantiles, because different drug specifications are measured in different units. For example, some drugs are measured in tablets, and they usually buy from 1 million till 10 million.
So Andrey, sorry. So my question is something like this. It's very hard to compare. So basically what you're doing here, you're saying, okay, so imagine I have an aspirin, which is bundled together with vitamins and antibiotics, okay? You're saying that, you know, I can compare this aspirin within a different bundle by making these parametric assumptions, right?
Parametric assumption on quantity, you mean?
On many things, because you cannot compare bundle effects, right? I mean, how do you control for bundled fixed effect if you want, right? Because the bidding happens at the bundle level, not at the individual prices level, right?
You're right. So I put number of drug specification.
Yeah, that's fine. This I understand, but that's linearly, right? And I mean, effects can be very funny.
So
right?
of course, and so again, my errors are clustered at the bundle level as well. Of course, ideally, I would like to run the regression separately for each drug specification, but this is impossible.
So did you try to do the same thing if you have only one drug within a bundle?
No, this is a good idea, I can. But the only problem which I see here is that I lose the instrument for number of applicants.
You lose the instrument.
Yeah, I lose instruments because share of treated drugs, that is actually bundling, is my instrument.
And then the second thing is
I don't want this discussion to be monopolized. Let's see if there is anyone else, and if we have time, then we'll get back to this, please. Any other questions from the audience, please? None? Okay, well, in that case, please, the floor is yours. Sorry.
So, Andrey, I'm working on a paper where I show that bundling decision is very endogenous one. So, you know, using bundles as instruments might not be a very good idea because it's a choice variable, right? So, and you don't want to use choice variable interacted with time as your instrument. And then the second comment which I had was about your story about these reserve prices, and then buyers setting them as a past, right? That's a very recent story, basically. You know, I think that's a story which kicks in, I don't know, 2018, 2019. So that story is wrong, most likely. So
I wouldn't agree with this. So starting from the 2019,
let's agree to disagree. But I have talked with people who, you know, it's fine.
Okay.
Okay. Well, thanks. That was quite useful. Please, any further questions, comments?
I would like to continue what Vitalis just pointed out about this regression on when the drug is unique in the auction, not in like the bundle. Because so what you are saying that you are pick up the price that they report in the contract, but it's not exactly the bidding price. Because for example, what I'm see in public procurement of gasoline, they also put the price of the 1 liter of the gasoline, but this price inside, it's sometimes it's far from reality. They just need to fix it, but it's not a strategic decision, this price. And the strategic decision is the price of the bundle. That's why I think you should think about another strategy where you could show the same result when you have only one drug in the auction, and you could say for sure that it is real unique price, especially in the case when you are not looking at the private market at all. And one more comment, it is nice to hear some story about the mergers that you just show up this table, and mergers, partly mergers, and it actually it seems it's not so clear and so straightforward why they are doing this. What is the aim of this merger? whether they are trying to keep the market or they try to influence prices. Because it's nice that you have a case of vertical integration, but it is nice to understand what are the incentives for the firm to do this. And in this case, it is more easier to say the story of what were confined in the influence, and especially in the public procurement market. And for me, the most weakest point here that 31%, okay, it is a big share, but vertical integration, mergers, and so on, it is a more complicated story than just story of the public procurement market. And you need to specify something behind this, what's going on. Because it is a second market, as we can say, this public procurement, not the first, from my point of view. And usually the decision is more complex than just bidding in certain auction, even if it is a really big one. But we can discuss later if you wish.
Yes, I think yes, we can do this. Thanks. Yeah,
and then just the last comment on your econometrics, you will have a lot of trouble with this diff and diff, because basically what you have treatment. Basically, you have treatments happening at different points, and then what you identify from that diff and diff regression is very unclear. So that I already sent you papers which can help you to address this thing. But you know, and then on top of that, in that diff and diff regression, you have a part which is instrumented. I really don't think that's gonna fly. So, you know, just drop the number of bidders and see what you're gonna have without controlling for number of bidders. Because if people will start nailing you on identifications, and basically people will say, look, you know, we don't know what you're identifying. You're identifying some weighted average, which doesn't have any meaning here. Okay.
Okay, thank you. I was thinking about number of applicants, but again, in this case, I should adopt my model properly, because then I should incorporate the endogenous entry, which is also I'm planning to do. Yes, but when I incorporate endogenous entry, I can drop out number of applicants. You're right. Thanks.
All good points. Thanks. Please, any further questions, comments? Well, looks like our time is up. Andrey, many thanks for this presentation.
Thanks you.
That was quite edifying for all of us, I guess. Thanks again, and Bernardo, please remind us what's coming up next, if you don't mind.
Yes. Well, thanks, Andrey, for your presentation, and well, thanks for all the participants. I think it was a very active meeting. Next Thursday, we have Silvia Griselda from the University of Melbourne. She will be presenting her paper, Can the Format of Questions Explain the Gender Gap in Mathematics?
Mm-hmm.
So it's going to be next week, same place, same time as usual.
All right. Thanks very much. We'll see each other in a week. Have a good evening. Bye-bye.